Alright guys, let's start the topic 2 review. Our first question says, which statement is true about parallel lines? And then our options are, they are coplanar and intersect. They are coplanar and they are not coplanar and intersect. They are coplanar and do not intersect. And they are not coplanar and do not intersect. So coplanar just means that they exist on a plane, which is just a flat surface. An easy way to think of a plane is a sheet of paper. So when we draw a line, it goes on a sheet of paper. So anywhere that it says not coplanar, I'm going to go ahead and rule that one out. Because we know when we draw lines, they definitely have to exist somewhere. And when we graph them, it's on the X and Y axis. So they're on the same plane. Then the question is, they are coplanar and intersect, or they do not intersect. Well, we know parallel lines continue forever in the same direction and they never intersect. So our first answer for this review is C. They are coplanar and they do not intersect. Number 2 through 5 use lines L and M are intersected by transversal T. L is parallel to M, so that's good to know. That's kind of what's up here, but just so we can get 2 through 4 on one screen, I went ahead and did this right here. And now let's talk about what it wants us to do. It says, which of the following angles are supplementary to angle 2? So supplementary and angle 2 are our key words here. And what I'm going to do is I'm going to come here to these. I'm going to first identify angle 2. So that's right here. And then it says supplementary. So what I'm going to do is I'm going to color code these, that all of the ones that are congruent are in purple, right? These are vertical angles, 2 and 3, so they're congruent. 2 and 7 are alternate because they're on opposite sides of the transversal. Interior because they're inside of the parallels, and they're angles, so they're alternate interior angles. And 2 and 6 are congruent because they're corresponding. I'm going to come in a different color, and I'm just going to mark all the ones that are supplementary. And that means they add up to 180 degrees. 2 and 1 are a linear pair. 2 and 4 are a linear pair. 2 and 5 are same side interior angles, so they're supplementary. And we don't have a specific thing here, but if I know that 2 and 6 are congruent and 6 and 8 are supplementary, then 2 and 8 would have to be supplementary. So angles 1, 4, 5, and 8 would all be correct answers for this question. And under our select all that apply, that's going to give me 5 here and 8 here. I guess I could leave the color coding. Let's see what the next question says. Which of the following angles are congruent? So here we'll do this. This one ended up being red for supplementary. Here we have our congruent angles in purple. Luckily we have 6, so this chart still works. So any angle that's equal to 6 will be in purple. So that is not 1. 2 is. 3 is in purple. And 4 is not. So that is how we would answer number 3. And then now it says, by which postulate or theorem is 1 congruent to 8? And I see here, since I did color code these, that this is true, that 1 and 8 are congruent because they're both in red. And that theorem is the alternate exterior angles, right? They're on the exterior of the parallels, and they're on alternate sides of this transversal. So here and here. So that'd be the alternate exterior angles theorem. Let's look at question number 5 next, which will also use this same chart. Now this one says, if the measure of angle 4 is 105 degrees, what is the measure of angle 5? So we know down here, angle 4 is 105 degrees. And it wants to know what is the measure of angle 5. Oh, angle 4 and 5 are alternate interior angles. The alternate interior angle theorem says that the alternate interior angles are congruent. So since 4 and 5 are alternate interior angles, angle 5 must also be 105 degrees. Question 6. Write two equations relating the measure of angle 4 to the measures of angles 1, 2, and 3. So it actually wants us to do 2 this time. So let's do that. Let's get a little bit larger of a work area. So we're going to have to use a couple, or yeah, literally a couple, 2 theorems here that will tell us what we have. So I want to know, how do I solve for angle 4? So this is my first example. Well, I can do this one right here is a linear pair. So the measure of angle 4 is equal to 180 degrees minus angle 1. Let's do the measure of angle 1. Let's write it very clearly. And my second way I can do it is by the remote interior angles theorem. And that just says that angle 2 plus the measure of angle 3 is equal to the measure of angle 4. Keep in mind that remote simply means isolated or far away. So if I'm looking at angle 4, it's not going to be the one that's a linear pair that makes this, added together makes this angle. It's the 2 that it does not touch. Angle 4 touches angle 1, so I'm not using that for the remote interior, because again, remote means isolated. So angle 2 and 3 are isolated from my angle 4. So if I add 2 and 3 together, I get the measure of angle 4. For 7, 8, and 9, we're using this triangle shown right here. And our first question is simply, what is x? So to solve for x, we're going to look at our diagram. And we're going to see that x is on the interior of this triangle. And it has 2 known angles for this triangle. So we know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 inside a triangle will always equal to 180. So I can say that 43 plus 75 plus x must equal 180. This is going to give me 118 plus x equals 180. And if I subtract 118 from both sides, I get x equals 62. Now it wants to know what is y. So actually, let me clear this. Pop in my answer here of 62. And then we need to look at what this is. So if I know this angle is 62, and I know that y, because this is a straight line, makes a linear pair with these two, right? So y plus x would equal 180 because they're linear pairs. And I know x is equal to 62. I can subtract 62 from both sides, and I would get y equals 118. So my answer for number 8 is y equals 118. And then number 9 is one of the more difficult ones because it says select all that apply. This being Savas, there's a chance that none, 1, 2, 3, or all 4 will be the correct answer. So we're going to analyze each one before we make a final determination on whether or not we're going to select it. So, which is true? Select all that apply. A, x equals y. Well, we've already shown that that's not true because 118 does not equal 62. So we're not going to pick that one. Y equals z. Here's y. Here's z. Y equals z is true. Oop, wrong tool. By the vertical angles theorem. And that's because here, if I look in just the inside of this square right here, I have two lines that are intersecting, and I can see that y and z are in fact vertical angles, just like x, and what I'm going to label as a here would be the other pair of vertical angles. So that is a definite yes on that one. Now we have x plus y equals 180. Well, that's how we solved for this one. So we're going to definitely say that one's true. And then x plus z, well, that's the same thing. That's just the other side of those vertical angles. So that one is true. Another way to look at these, since I did kind of do them a little quick there, is let's clear the screen and just talk about x plus y again. X plus y being 180 is definitely true because they're linear pairs. And then at the same time, x and z are definitely linear pairs. So for number 9, B, C, and D would all be correct choices. Questions 11 through 15 require this diagram. So I just took a screenshot of the questions so that we can use the diagram a little bit larger and easier for us to see. 11 says, which pair of lines are parallel? And then we have our choices. I'm going to ignore the choices and I'm going to look at the diagram first to see if I can come up with some reasoning that would allow me to convince myself that whatever I come up with is the answer that should be expected. And that way I can feel more confident than if I were to try and look at A, then look at B, look at C, look at D, and hope that. So if I do that first, there's a small chance that seeing those answers may sway my view or give me some bias. So if I don't look at those and I try and do this on my own first, I can have a better confidence level moving on. So if I'm looking at this, it wants to know what lines are parallel. Well, I know we can't trust our eyes, but I can say assume C is parallel to D, and then I would show it. And then if I can come up with one of our theorems that shows C is parallel to D, I've done a really, really lightweight proof there. And I can go back and check and see if one of the options tell me that C and D are parallel. And then just by using my eyes for a little bit of background information, doing a very, very lightweight proof, I can then say I feel really confident. So if these are parallel lines, A and B could be transversals. We could treat these as transversals, but they don't quite extend enough. So I'm going to go ahead and say that these are not going to be the ones I should be looking at. So if I treat A as my transversal, I have 109 here. Alternate exterior angles would tell me what that is. A linear pair would tell me this is 71. This would be 71 by vertical angles and linear pairs. And then because these are vertical angles here, and these are linear pairs here, I can do this. And since I'm using A as my transversal, I can draw my box like I talked about in class. Split it up. And then apply that same corresponding rule down here. Now, I'm sure a lot of you are watching this and you've already moved past this box method that I showed you, and that's fine. But just for a chance for everyone to see it again, I'm going to go ahead and do it. Whatever's in my top left box goes into my top left box here. So that's 109. Top right is 71. My bottom right is 109. So it looks like we're accidentally finding some answers here ahead of time. So nothing here. No, that's not true at all. Quite a bit here tells me that C and D are parallel. I can do this by the same side interior angles theorem and show that this 109 and this 71 are supplementary. And that will actually satisfy it. I can do alternate exterior angles theorem. That's this one and this one. Since they're the same, I can say it's true by that. I can do corresponding angles because that's how I built the thing. So probably not the best idea to use the method that we used in our proof as the pure justification. But we can, because we did really use the linear pairs theorem to start this and move on from there. Here, any of those work. Any of the corresponding, so I'm just going to write any instead of writing every one of those. So yeah, we can say definitely that C and D are the parallel lines. So let me clear this. And that's my first answer. We just had X here, but again, since we now know C and D are parallel by the alternate exterior angles, we would say that X is 109. And where's my Y? All right, so we've done no work for Y yet. But I see that Y is on the inside of a triangle. And I know that if I add these three angles together, I will know that they have to equal 180. So 55 plus 41 plus X is 180. This becomes 96 plus X is equal to 180. Which would be, when I subtract 96 from both sides, this would give me 84. And then, so now we know, I guess I could have put here a Y, right? Because that's actually what we're solving for. Now that I know that Y is 84, by the vertical angles, I can say these are equal, and it's just a little less messy. Now I can say that 84 and Z are a linear pair. Well, I already know that 96 plus the 84 gives me 180, so my answer here is 96. But let me do a little bit of math here to convince you. This is my linear pair. 84 plus Z must equal 180. Subtract 84 from both sides, just like we kind of did down here. And we can rediscover that we are in fact looking at 96. Final question is if the slope of line D is given, the slope of which other line is known? Well, if we go back up here, we know these are parallel. So the slope of C is going to be equal to the slope of D. So if we know D, then the slope of C must be equal. All right, so let's look at number 16. I'm not even going to look at the options for the review, the answer options, because I'm just going to solve it. And then we're going to see that we're confident enough in our abilities that we can then move on to question 17 and feel good about the exam that's upcoming. And I'm going to go ahead and do this a second time. So we're going to call this one 16A. 16B, I'll do it for parallel. Obviously, it won't be on your review, but parallel could be on your exam. So I want to at least make sure we visit that one more time just so we can all see it. So it says, what is the equation of a line that is perpendicular? So remember the symbol for perpendicular is this upside down T. And it means that they meet at 90 degrees. So what is the equation of a line that is perpendicular to this line, y equals 2x plus 1, and passes through the point 4, 6? So first thing we must know is that line 1 is y equals 2x plus 1. And looking at this, that means our first slope is just 2. So m1 is equal to 2. And we need line 2 to be perpendicular. So we have to ask ourselves, 2 times what number equals -1? Divide by 2 both times, and we get x equals -1/2. So I know my perpendicular slope is this. So I'm going to rewrite this as y equals -1/2 x. Let's make a little bit more room there. And I'm not going to put my plus b part, right? Because remember, this is a line in the form of y equals mx plus b, because we don't know what b is yet. And if you're following those steps when you do this problem, it just says set it up to here. And I need to now plug in these points to get my b. So I guess I could go ahead and write plus b. Now I know my y value, right? Here's x. Here's y is going to be 6 is equal to -1/2 times 4 plus b. And this is going to give me 6 is equal to -2 plus b. And then add 2 to both sides, and I get b is equal to 8. So my final answer will be y equals -1/2 x, just like I had here, because that is my perpendicular slope, and then my b is 8. That's where I adjust vertically to make sure it passes through the point 4, 6. And then, as always, let's check it. And to check it, we take our slope, or we take our new line, and we plug in our points. And if it's true, we have done it correctly. So my y equals -1/2 times 4 plus 8. And this gives me 6 is equal to -2 plus 8. And that ends up to be 6 is equal to 6, which is true. So this is the equation of a line that is perpendicular to our given line and that passes through the point 4, 6. Let's do this again, but let's make it parallel this time. So this time, we still have the same slope. And that is a 2. Now, since we went parallel, we don't do anything. We copy our slope exactly as it is, because these never intersect and they are coplanar. But what does change is this becomes y equals 2x plus b, and we need to figure out what is b going to be so that this line passes through 4, 6. And to do that, with my rewriting with my second slope, I'm going to have 6 is equal to 2 times 4 plus b. This is going to be 6 is equal to 8 plus b. Subtract my 8 from both sides, and I get b is equal to -2, which means I can combine this equation with my b answer, and I get y equals 2x plus, that would be -2. Let's check it to make sure we've done everything right. Here I'm going to plug in my 6 because that's my y coordinate. Here I plug in my x. This is 6 is equal to 2 times 4 minus 2. And we can already see that this is looking great. That 6 does in fact equal 6. So this line and our given line are parallel to each other. And the line that we found does pass through the point 4, 6. Now let's go back and look at our original line where we got y equals -1/2 x plus 8. And let's see if that is one of our answer options. So we had y equals -1/2 x plus 8. That is it. So we would choose C for this one. That's perpendicular. As the first example I did on this question with the line y equals 2x plus 1, This is not the parallel one. This is the perpendicular one. And we can see much more easily if you guys wanted a shortcut. Not even a shortcut. If you want another way to do it, especially when you're given a multiple choice exam, we know we need perpendicular. So I just take my slope, flip it upside down. So this is 2 over 1. Flipping it gives me 1/2. Multiply that by -1. And I get y equals -1/2 x plus b. And already I can see that this one and this one are out of the running. Now I just need to know, is it going to be +6 or +8? Throw in my points. Well, I guess we could, no, I don't want to write it. We could do that because multiplication is commutative, but let's keep it in exactly the order that it is shown. This gives me 6 is equal to -2 plus b. Add 2 to both sides, and I get 8 is equal to b. C is my final answer. So we've done that a couple times now. Hopefully that helps. Let's look at our last few. What is the slope of a line parallel to the line y equals 3x minus 4? I really couldn't make this one any easier, right? Parallel just means I copy the slope. My slope is 3. So my new slope must be 3 as well. Since it's already defined as slope, I would say for Pearson, we're just going to, or for Savas, we're only going to put the number 3, and that should be sufficient. We shouldn't need m equals 3. If you put m equals whatever, and it's the right slope on the test, of course I can add those points back. I'm not going to take them away from you. All right, 18 and 20 needs this map. So let's zoom out just a tiny bit. Take a screenshot of it. And then we can look at our questions. This is the 18 through 20. Okay, yeah. Which street is perpendicular to First Avenue? So let's look at where First Avenue is. And I'm just going to draw this. So here's First Avenue. Let's pick a different color. That would probably be easier to see. So First Avenue is here. And it says what street is perpendicular? Well, even though it's not by inspection, right? We can say that's not it. We can say that's not it. And if you copied all your theorems, you kind of have, you can see here that there's no rise at all, but there is plenty of run. So this is a 0 slope. And here for D Street, all we have is rise and no run. So let's talk about what those slopes actually are. For this one, where I have 0 rise, but I do have run, I get 0. So for this one, m equals 0. And for this one, I have plenty of rise, but no run. So this is undefined, making this slope undefined. And in your notes, you automatically know that if a 0 slope and an undefined slope meet, they are perpendicular to each other. So First Avenue and D Street would be perpendicular to each other. Question 19 says, a city planner wants to build a road parallel to 2nd Avenue. What is the slope of the new road? So let's find 2nd Avenue. Well, here we've already determined that First Avenue has a slope of 0. We can see that there is absolutely no rise in 2nd Avenue. So I'm just going to call that M2. This would be M1, and this would be MD. M2 has absolutely no slope. And since we want it to be parallel, this would also have to have absolutely no slope. Question 20 has a select all that apply. So let's scroll down just a little bit. If the measure of angle 5 is equal to x, let's just go ahead and throw that in there. Here is 5. Which angles have a measure of 180 minus x? All right, this one's pretty funny because we've already shown that that first So let's say the slope of first is perpendicular to the slope of D, right? Because one's horizontal, one's vertical, one's zero slope, one's undefined. If these are perpendicular to each other, then the measure of angle 5 is just 90 degrees. And since all of these are linear pairs to each other, and by vertical angles theorem, all of these angles are 90 degrees. And now that we know that, by the corresponding angles theorem, we can drop all this information down. So the joke here, I guess, right? What does Savas want you to see? What do they want you to get a chuckle out while you're taking this exam? Is that if I color code them for what's equal, all of these are equal, and all of these satisfy this. So basically, if it exists on either of these two lines, it is a correct answer for question 20. Angle 2 is way over here, right? So that is a no-go. So it's not angle 2. Angle 3 is also over here. Can't be that. Angle 7 and 11 are part of this. So our answers are 7 and 11. Now, I know I said that they're automatically equal to each other, but let me just show you why. Again, if we know this one's 90 and these form a linear pair, I can plug 90 in here and I get back 90, and 90 is equal to 90 is true. So for all of these, they're all linear pairs, however we want to look at it. We're going to get that same answer there by the vertical angles theorem or the linear pairs theorem, but we're just getting it over and over again. And then the corresponding angles theorem, you can draw your box if you like. You can do this mental slide down if you like, or as you get more comfortable with this, automatically just recognize that those are all congruent. So this is your topic 2 review. I am posting this link, the link to this video on Google Classroom. I want you to submit your review to this link. This will be live at noon. The post for this will go live at 8 a.m. So if you already have it done, I'll put in the notes. Go ahead and turn it in. But if you haven't finished it, use this to help you. Definitely review your answers. If you did well on this, you can expect to do well on the exam.